Hello and welcome to this tutorial about the I/O example. I've copied the workspace to example workspace directory, and let's look what we have here. So we have several configurations. In this video I'm going to talk about these four. I2C and GPIO will be the next video. So here we talk about network communication, UART communication, and stream to packet. So let's start with TCP/IP. Let's compile this, open the view, nothing big here. Then let's open the model. So what we have here is we've entered a string, send to all, forward on change, a TCP server, a cast to a string or a conversion to a string, and here a print function, which adds a prefix. And here this one adds a prefix too. Here we have the client, the conversion, the forward on change, and here we have enter a string to send. So it started. Let's see what it does. Send. So this is received by the server. It's received by the client. So let's look a bit into the server here. As input and output, there's a blob. We can look into the documentation here. What this blob does, it's holding a container with data and size. You can get stuff, set stuff. Here's access without limit checking, and you convert it to a string. That's what's done here. This is called here. It's not necessarily needed because there's also a cast operator for string. Let's try this here. So that should work too. This cast operator is new, so this is a bit an older example. Okay. Here's the shared blob. It's it's deriven. I don't know what's the real word. So yeah, it's a blob. It holds a shared pointer and has some additional methods like realloc, reset, and a plus operator. That's very useful when you want to add things together. So you could do things like, is this already a blob? No, it's a string. So let's see. Yeah. So this output can be added to something. Yeah. I make another example. In the stream to packet, we will talk about that once again. Forward on change, nothing big here. The string is delayed by 1, and when they are unequal, in is forwarded, elsewhere there's nothing forward. So yeah, we can here's an example how you can use this with netcat. So let's do that, try that once. So now we are connected to the server. Hello and see. So it's receiving what I've sent it. Let's send something to all. Send to all 2. So it's received by the client and it's received by netcat. So that's basically it for the TCP/IP. Let's look into the model for UART. It's basically the same. UART also has input and output blobs. So I won't run this model for you now. It's pretty simple. And UDP, it's also basically the same. We have a receive node, a send node. Yeah, the difference between UDP and TCP/IP is that we have streams, and in UDP we have packets. So every time you send something via UDP, this whole blob is received as in one tick via this receiver. So you don't have to segmentize or have start and stop bits and something like that. So UDP is much easier. It has less overhead. Yeah, I use it most of the times because yeah, sometimes when it's delayed or it's the package is lost, I don't need it anymore. So yeah, when you're sending something via network, when you're doing controlling stuff, yeah, it's better for me. So yeah. Okay, so that's it for these three projects. Let's do stream to packet. Start this. Already open the model. So here we have a webcam, we have a serialization node, we have a stream to packet node, the TCP server we have seen. Here we have a client, a decoder, and a deserialization. So what this does, it takes whatever the input is, serializes it into a blob. So let's look into this very small node. It's the same mechanism as record and playback. So yeah, here it converts this input into this blob, and here's written how it's done. Basically, it's taken the definition size, the data size, and then puts in the definition and the data. So yeah, and everything is in a blob. Then this is put into the stream to packet format. So stream to packet adds an header, adds an ID that you can set here. Look into this here. So also uses blob shared blobs. So as in an output, yeah, it makes a header, it adds a checksum, and that's basically it. And then you can decode it, or you can get your packages decoded here. If you had another package with another ID, for example 101, then you would decode it like this and then deserialize it. When you need it, you just, or you can cast it, just do it like you want to. Yeah, so that's basically how you use it. Maybe when I show you another example, I will reuse it and then you see it in action. Yeah, but that's basically how you send stuff via TCP IP to another computer. So let's look into the view. Nothing to see here. So bye bye. See you.